CNN on convolutional neural network. This is a numerical part of CNN in which we have one image matrix. This image matrix is a sample image matrix whose dimension is 6 cross 6, and we have a kernel or a filter which is given to us. Both of these information is given to us, and this kernel or filter is of 3 cross 3 dimensions. Stride is given to us as 1 and padding given to us is none. Now, the output matrix dimensions can be calculated using this formula, m minus n by s plus 1. Here, m is the dimension of our image matrix, n is the dimension of a kernel or filter, and s is our stride. And how exactly do we solve this? Using this formula, we can only get the dimensions of the output matrix. But how do we actually solve a CNN or convolutional neural network, or how does the computer solves CNN or convolutional neural network? We take the filter matrix of the kernel and place it on the leftmost corner. When we place this on the leftmost corner, it will come overlap with this part of our image matrix. Then we convolve it, which here means that we multiply the respective element with the respective element of the kernel, and we add all the products. The same thing we have done over here. We have the leftmost uppermost corner of our image matrix, which is same, and we have our kernel or the filter. We have multiplied all the individual elements of these matrix. 1 multiplied by 1 is 1, anything multiplied by 0 is 0, and anything multiplied by minus 1 is minus of the same number. And then we have sum all of these. That means 1 plus 0 plus minus 9 plus 2 plus 0 plus minus 1 plus 3 plus 0 plus minus 4, which gives us our step 1 row 1 answer, which is minus 8. Now we are done with the first leftmost uppermost corner of our image matrix, and since stride given to us is 1, we will move one step ahead, which means now the image kernel will go onto this matrix, this 3 cross 3 submatrix of our image. When we do that, we will get the following, and in the similar way we will multiply each of the elements and get our resultant matrix, and then we will sum all the elements in our resultant matrix to get the final sum. Now if we see, this image kernel or this filter can go only 4 times: first, second, third and fourth, when in one go. After completing all the 4 steps, it will come down just one step. 1 comes from this stride. If the stride was 2, then in the second step row 1, step 2, we would have gone, instead of this matrix, we would have jumped 2 steps. We would have gone here. This matrix would be the one we would be calculating in row 1, step 2. And when we would have exhausted this complete row, we would have jumped up to 2 steps below, which means we would have come here and then we would have calculated this matrix convolution with the kernel or the filter matrix, and that is how we would have proceeded. But since the stride is 1, we would only go 1 row down, and then we will calculate the matrix with using this submatrix from the image, which is the same thing that we have done in row 2, step 1, which is we have taken this submatrix and done the convolution of it with our filter matrix to do the same steps and get the answer as 6. The same we will do for all the rows. Then we will do for this submatrix, then the next submatrix, and then the next submatrix. After exhausting the complete image matrix using our kernel or filter, that we have no other next row to go to, that is when we will arrange our all the answers in form of an output matrix. This is the answer of row 1 step 1, row 1 step 2, row 1 step 3 and row 1 step 4. This is how we get our output matrix. And as we can see, the dimension of this output matrix are 4 cross 4, which we can also verify from our formula, which was m minus n divided by s plus 1. M is the dimension of our image matrix, N is the dimension of our kernel or filter matrix, and S is our stride. 6 minus 3 divided by 1, which comes out to be 3, plus 1, which is 4, which means the dimension of our output matrix should be 4, and hence it is also verified by our actual output matrix over here.